In this video, we will see about the different type of losses that occur in a transformer. We have already seen about the transformer basics in the previous video. Let us recall some of the important points so that it will be useful for this particular video. So the transformer is a static piece of apparatus used to transfer electrical energy from one circuit to another. So we have primary winding and secondary winding. We give alternating voltage to the primary winding and load will be connected at the secondary winding. So the transformer always works with alternating current, and the voltage, output voltage, can be increased or decreased depending upon the requirement. So that will be decided by the transformation ratio or turns ratio of the transformer. And the power in a transformer remains the same. So V1 I1 will be equal to V2 I2, and there will be no change in the frequency. The main parts of the transformer are the magnetic core and the winding. So based on the manner in which the windings are wound on the core, the transformer is classified into two types, core type and shell type. So in core type, the core is here and the windings are surrounding the core, whereas in shell type, you see the windings are inside and core is surrounding it. So this is the major difference. So let us see the difference between core type and shell type. So it is here, there is one magnetic flux path is there, and primary winding is connected in one limb and secondary winding is connected in one limb. So this structure is called core type transformer. So in shell type, you will have three limbs and both the primary winding and secondary winding are wound over the same leg. So here it has two limbs and here it has three limbs. And here the windings surround the core, whereas here core is surrounding the windings. The major difference is that here the leakage flux is more because primary winding is in one limb and secondary winding is in another limb. So the linkage, flux linkage may not be very efficient in case of core type transformer. So leakage flux is more. Whereas in shell type, both the windings are very close together. So the flux linkage is more and leakage flux will be less. In core type transformer, the copper requirement is more compared to the shell type transformer. Moreover, the maintenance will be easy in case of core type transformer because you can easily remove the primary winding or secondary winding because they are separate. Whereas in case of shell type, it will be difficult to remove the windings for maintenance. And in core type, natural cooling is possible, whereas in shell type, the cooling is not that much efficient as the windings are tightly packed. And core type is useful for high voltage applications like auto transformer, whereas shell type is used for small low voltage applications and small electronic projects. We can use shell type transformer. Let us see about the different losses that occur in a transformer. So the losses in a transformer are basically classified into two types, copper losses and iron losses. So if you see iron losses, there will be hysteresis loss as well as eddy current loss. First, let us see about the iron loss or the core loss in a transformer. We can see here, this is the core of the transformer and the flux is passing here. Since the flux remains almost constant for all the loads, the core loss remains the same at all loads in a transformer. So core loss is constant in transformer. And this core loss can be minimized by using, if you change the material of the core loss is going to change. So the loss can be minimized by using silicon steel for the core and very thin laminations like this. And the magnitude of the core loss component can be easily found from the open circuit test. First, let us see about the hysteresis loss. So core loss is hysteresis loss plus eddy current loss, and here we are going to see about hysteresis loss. The term hysteresis, we know it is due to the magnetic property of the core. That is, when you apply a AC voltage, the core will be subjected to magnetization and demagnetization in every cycle. That is, you are giving a sinusoidal current. So if you see here, when the current increases from 0 to its maximum value, the curve is OGP. But when the current decreases from maximum to 0, it will not follow the same path. Actually, it should have followed the same path and come 0, but it will not do it. It rather comes to this point T. So even though the current has become 0, the flux density is not 0. So you have to apply in the reverse direction to make this flux density 0. So this leads to hysteresis loss. Hysteresis loss is given by this formula, or we can say it is directly proportional to the flux density as well as frequency. So F is the supply frequency, Bm is the flux density, and V is the volume of material. Next we have eddy current loss. Actually, in the core we have windings and we are passing alternating current to the winding. Due to that, EMF will be induced. Due to that induced EMF, there is a current induced in the core itself. That is called eddy current. So it is not going to contribute to any useful work, rather it heats the core. So it is essentially a I square R loss occurring inside the core. Eddy current loss is given by this formula. So it is directly proportional to the frequency square. Next we have copper loss. So the copper loss is due to the ohmic resistance of the transformer winding, because windings have resistance. Because of the resistance, I square R loss will be there. So this I actually depends upon the load. So the copper loss varies as the load varies. So it is called a variable loss. So the copper loss can be found from the short circuit test on the transformer. Let us see the efficiency of a transformer. Efficiency is given by output by input. So if you want percentage, multiply by 100. In general, the efficiency of a transformer will be very high. That is 95 to 99% you can get efficiency. So this efficiency of the transformer will be maximum when its copper loss is equal to iron loss. Next, there is an important question. which will be normally asked in all exams. Why transformers are rated in kVA? So have you seen this transformers? They are written in 3200 kVA. kVA is there, not in kilowatt. If you see motors, you can see that they are rated as 2 kilowatt motor, or if you see a heater, it will be 1 kilowatt heater, whereas the generator or alternator, they have kVA rating. So what is the difference? Here you know what work the motor is going to do and what this heater is going to do. So it is specified in kilowatt, or you know the power factor of these things, you can mention it in kilowatt. But for transformer and alternator, we don't know what type of load will be connected. So it depends upon what load you connect. The load is going to determine how much power it is going to draw from the transformer. So normally it will be given in kVA by the manufacturer, because they don't know what type of load will be connected for the transformer and alternators. So you should know what is active power, reactive power and apparent power. So in active power, it is equal to VI cos phi, that is power factor is included in active power. In reactive power, you have VI sin pi, so it is kVAR, that is kVA reactive, and apparent power is VI. There is no power factor here. So for transformer and alternators, only this apparent power is specified, because we are not talking about power factor here. So this is the power triangle. If this P is the active power, Q and reactive power, S will be your apparent power. So there are two things to be noted here. The transformers, we don't know what will be the load power factor. If I connect a resistive load, I can draw the full power from the transformer, but if I connect a RL load or a lagging power factor load, the power drawn will reduce due to the lagging power factor. So the load will determine the amount of power drawn from the transformer. Second thing, the core loss depends upon voltage and copper loss depends upon the current in a transformer. So the losses are independent of the power factor. So normally transformers are rated in kVA. So the points to remember here are, the losses in a transformer are broadly classified into two types, copper loss and iron loss. Iron loss, you have hysteresis loss and eddy current loss. And the transformers, normally they have very high efficiency, greater than 95%, and transformers are normally rated in kVA. If you like the video, do subscribe to Read Electric Vehicle channel. Thank you.